In this video, we're going to talk about revenue and profit. So let's begin by defining revenue. So revenue is the total amount of income that we receive from some business transactions. All right, so let's look at an example to see what this looks like in practice. Okay, so this is example 3. Again, continuing the numbering from the previous examples in this section. So a store charges $35 for a pair of jeans. What is the store's revenue if it sells in part A 20 jeans and in part B X jeans? So the revenue that the store gets from selling these 20 jeans is sort of collectively how much income the store gets from the customers paying for these 20 jeans. Okay, so let's see if we can compute this. So the revenue. So just sort of intuitively, if each pair of jeans costs $35 and the store sold 20 of them, I need to multiply the 35 and the 20 together. But I want to be more general than this first. I want to try to write down a more general formula. So in general, the revenue is going to be the price of each item times the quantity. So the revenue equals the price times the quantity. And this formula is true when the price of all the items, in this case all of these jeans, all copies of this item, all items is the same. So if some of the jeans cost $35, but some of the other jeans cost $40 and some other ones cost $15, we couldn't use this formula. We'd have to break it down a little bit more. But when all the items have the same price, we can use this formula. Okay, so this is an important formula, so I'm going to highlight this. Revenue equals price times quantity. So the price here is $35 per pair of jeans, so $35 per jean, times quantity, and there's 20 jeans being sold. And when we multiply these, this jean on the denominator cancels with this jean in the numerator. So the units I'm left with are going to be dollars. And 35 times 20, that's 700. So 700 is their revenue. Okay. So one important thing to note about this, and to be careful about, is the store's revenue is a cost for someone else, is a cost for the customers in this case. So reading this problem, a common way to read this would be to say that when it says the store charges $35, sort of conceptually that means that jeans cost, keyword cost, $35. But who does that cost go to? That cost goes to the customers. And that's important. Okay, so let's do part B. Part B is asking about what if there's X jeans? So there's X jeans. So I'm going to call this thing a revenue function because I'm writing it in terms of a variable. And I'm going to call it R of X. So revenue is a function of X. So again, I'm multiplying the price times the quantity. So we get Rx equals, so the price is $35 a pair times the quantity, which is now X. So the quantity is now X. We'll get 35 times X, and we can't forget the units. So the units here are going to be dollars. So that's R of X. That's our revenue function here. And notice that this is a linear function. And that's what we're dealing with primarily in this section. In later sections, we're going to start to talk about other types of functions like quadratics and exponentials and log functions. But right now, we're just dealing with linear functions. All right, so let's look at another part of this problem. So this part C says, the production cost to the store of selling 82 jeans is $3,650, and the cost of selling 100 jeans is $4,100. Write C, the cost, as a function of X, the number of jeans produced, and assume C is a linear function. Okay, so I have this I'm assuming c is a linear function, and I need to write down its equation. All right, so to do this, it would be helpful if I had some points, so some x comma y's. But in this problem, y is actually c. It's the cost, or c. So if I think about the information the problem tells me, so it tells me when the store sells 82 jeans, so that's when x is 82, that the cost is $36.50. So that's the y value, or the c value. So that is 1 point. And in the same way, when the store sells 100 jeans, when it sells the 100 jeans that it produces, so that's my x value, the y value, the cost, the c value, I guess, is 4,100. So we have these 2 points, and I need to write down the equation of the line that goes through them. Okay, so to do this, let's think about slope-intercept form or point-slope form. So pause the video for about 30 seconds and think about what seems like it would be easier here, slope-intercept form or point-slope form. 4, 3, 2, 1, pause the video. Pause the video for about 30 seconds and really think about this. Seize this time to think about this problem. That way, when you go to try similar problems that show up on homework assignments, or maybe on a quiz or a test, you've already gone through the process of thinking about this before, so that you can use what you learned from this experience to help you in those future problem-solving attempts. Okay, so let's go ahead and talk about this. So the y-intercept here is unknown. And when we don't know the y-intercept, point-slope form is easier to use. Point-slope form is easier. Okay, so let's go ahead and write down the slope first. So the slope is going to be change in y, 4,100 minus 3650 over the corresponding change in x, 100 minus 82. So the numerator is 450, the denominator is 18. So I could simplify this. I could divide the top and the bottom by 9, and that gives me 50 over 2. And 50 over 2, that's 25. So that's my slope. And now I can go ahead and write down the equation in point-slope form, which is y minus y1 equals m times x minus x1. And I know what the slope is, so I know I'm going to plug in 25 for the m. And for x1, y1, I get to choose either of these 2 points. So for the sake of algebra, I think the second point seems easier, because 100 seems a whole lot easier to work with than 82. And same thing even with 4,100. It just has more zeros. So y minus 4,100, and then I get x minus 100 in here. Okay, so let's remember here that in my problem, I don't have y as a variable. I have c. So here y is actually c. So I have c, and I want to write c as a function of x. That's what it said to do, right? C as a function of x, which means I don't get to stop here. I have to isolate c. So if I distribute 25, we get 25x minus 2,500. And if I add the 4,100, so plus 4,100, and simplify, we get c equals 25x minus 1,600. And that is our cost function. And it has units. The units are dollars, so I can't forget about those. And that's my cost function right there. Okay, so that was a little bit of review. Actually, let's continue doing some review. Let's see if we can determine what the variable, marginal, and fixed costs are here. All right, so the variable cost is the thing that has an x. So it's the mx part. It's the 25x. That's the cost that's changing here. The marginal cost is how much the cost goes up for each additional unit. So the slope is what tells us the marginal cost, and that is 25. And for the fixed cost, oh, it looks like I think I may have made a sign error. Yeah, minus 2,500 plus 4,100, that should be a positive number. This should be plus 1,600. Actually, if not, my fixed cost would have been a negative number, which is a little bit weird. So now my fixed cost is $1,600. That's the part of this cost function that is not changing based on X. That's what makes it fixed. And the units for all of these are dollars. So units of these are all dollars. Okay, so that's a little bit more of just review. All right, so now that we've talked about revenue, let's talk about profit. So profit is the net amount. I'm going to highlight this. It's the net amount of money that's received after some business transactions. And this is after subtracting the costs. So if I had to write this with an equation, the equation is profit equals the revenue minus the cost. Okay, so I'm going to box this. I'm going to highlight this in yellow. This is an important equation, maybe one of the more important equations that we are going to see in these earlier review chapters. Okay, so now if I write this with function notation, I'm going to call the profit P of X. Revenue, let's call that R of X. And then minus cost, let's call that C of X. And let's figure out the profit for our previous example. So the revenue we figured out earlier, that was 35x. That was way up here. Revenue was 35x. The cost we just got. The cost was 25x plus 1600. So let's go ahead and plug that in. So 25x plus 1600. So 25x plus 1600. I've actually made a mistake. What's my mistake there? See if you can catch this. Think about this one more time for 30 seconds. 4, 3, 2, 1. Pause the video. Pause it for 30 seconds and see if you can spot what was my mistake here when I subtracted this. All right, so hopefully you've done that. Hopefully you've paused it for 30 seconds and thought about this. My mistake is I forgot this parentheses. I'm subtracting this whole thing, and to indicate that I'm subtracting the whole thing, I need a parentheses around that whole thing. Otherwise, I'm going to forget to distribute the negative to both of these terms. Okay, so we have this for the profit. Now let's go ahead and distribute that negative and simplify. Okay, so if we do that, we end up with profit P of X equals 10x minus 1600. And profit has units, which are dollars. So that's my profit function for this problem. So now let's answer a couple of questions related to this. So first, what is the store's profit from selling 100 jeans and then 200 jeans? So from 100 jeans, what I need to do is, that's my quantity, that's X. I need to plug in 100 in for the X. So I want to know what is P of 100. So plug in 100 for the X. I get 10 times 100 minus 1600. So 10 times 100 is 1000 minus 1600. That is negative 600. And there's units, so let's not forget about those. Negative $600. So usually in problems like these where there are units, I like to just add those at the end. Okay, and let's just also interpret, what does this mean if my profit is negative? This means that the store has what's called a loss. The store has a loss of $600 if it sells 100 jeans. If it sells 100 jeans, overall, it's down $600. Overall, it'll have $600 less than what it started with. Okay, so now let's do the same thing for 200 jeans. So for 200, I need to do P of 200. Let's plug in 200. So I get 10 times, now X is 200, and then minus 1600. So multiplying, I get 2000 minus 1600, which is 400. Let's not forget the units, so $400. So now that's a positive number. So the store is actually making a profit, a positive profit, when it sells 200 jeans. So writing that down, we would say that the store actually has a profit now, actually has a profit of $400, positive $400, if it sells 200 jeans. Okay, so a really common business econ question when questions talk about profit is how many jeans must be sold to do what's called breaking even, to break even. Okay, so if I want to break even, what that means is I want the profit to be equal to 0. Okay, so I want to figure out when we break even. How many jeans would it take for the profit to be 0? So if I want my profit, which is P of X, to equal 0, let's set P of X equal to 0. Oh, so P of X, my profit function from above, was 10x minus 1600. And I want that to be equal to 0. So let's move the 1600 over. That gives me 10x equals positive 1600. And then if I divide by 10, we get x equals 160. But there are units. X was how many jeans? How many jeans the store sold? So it would have to sell 160 jeans to break even. And just doing a reality check, if I think about the numbers that we had above here, when the store sold 100 jeans, it was in the, so to speak, it was in the red. It had a loss. It was losing $600. But when they increased the quantity sold to 200 jeans, it was making a profit. So assuming that profit is a linear function, which it is here, we'd expect that break-even point when the profit is 0 to be somewhere between 100 and 200. And it makes sense that I was getting a value like, what did we get? 160, which is between 100 and 200. Okay, so I want to end this video by drawing a couple of pictures to help us visualize what this break-even point, in fact, let me highlight this word. This is a key term from this section. What that break-even point looks like. So sometimes we call this specific number that where the break-even point happened. We call this the break-even point. All right. So let's draw some pictures. So I'm going to draw 2 pictures. In this first set of axes, I'm going to consider the revenue and cost functions. In the second picture, in the second set of axes, I'm going to consider the profit function. Okay, so let's remind ourselves. Our revenue function was 35x. So that means the slope is positive. 35, and there's no y-intercept because it's just 35x, so the y-intercept technically is 0. And the cost function was 25x plus 1600, so the y-intercept was 1600, but the slope is not quite as big, so this line is not going to be quite as steep. So my cost function is going to look something like this. So c of x equals 25x plus 1600. That was our cost function. Now let me also put some arrows on the revenue function. So the break-even point is where the revenue and the cost equal each other, because that's where the profit is going to be 0. So this value right here, this is where the 160 occurs. That is the break-even point. It's happening where 160 jeans is. Okay, so now I'm drawing a picture of the profit function. So the profit function was this over here, 10x minus 1600. So if I draw that, the y-intercept is negative 1600. And the slope is 10, positive 10. So it's going upwards. Okay, so that's my line. And in this graph, the break-even point is the point where the profit equals 0. So this is where 160 jeans is. That is my break-even point. So in this graph, for this part of the graph, the part of the graph that is to the left of the break-even point, my profit function is negative. So that corresponds to where we have a loss. In my other picture, we have a loss when the cost is higher than the revenue. If I have more cost than I'm receiving income from the revenue, that means I'm losing money. So that is also over here to the left. We have a loss here because the cost is higher than the revenue. And in this profit graph, we have a positive profit. Maybe I should say positive profit. Because the profit is positive here. I could see that from the graph. Even in this other graph here with the revenue and the cost, to the right of 1600, we have a positive profit because the revenue is higher than the cost. So at this point, we have made it to the end of learning goal 2. We've defined cost in the last video, and in this video, revenue and profit, written them as linear functions, and found the break-even point, which happened when the cost and the revenue were the same. In other words, where the profit equaled 0.